Okay, let's give you guys some more practice. So determine if this integral will diverge or if it's going to converge. So press pause and have a go. Okay, so to do this, because dead on zero breaks down, dead on zero, this whole thing here breaks down. Then we need to break this up into two separate integrals. So we need to break this thing up into two separate integrals. One from 0 to 1, so one from 0 to 1, and the other one being from 1 to infinity, from 1 all the way to infinity. Let's just randomly look at this one first. Later on, we will look at this thing here. So for the time being, forget about this. Let's just try and determine if this will converge or if this will diverge. So looking at this, hang on. Now looking at this, we need to do this. We need to compare this with this, because at the moment you've got one thing multiplying with another thing. So in the region from 0 to 1, so here you've got one thing adding another thing. So in the region of 0 to 1, it's like this bit here, it's like you adding, let's say 0.3. So here you've got 1 add 0.3, because this 0.3 has to be in between 0 and 1. So this bit here is going to be 1 plus a tiny bit. So this is going to be a number bigger than 1. This number is going to be bigger. This thing here is going to be slightly bigger than 1. So here you've got one thing multiplying, and you're going to multiply something that's slightly bigger than 1. Well, if you omit this, then the overall thing, if you omit it, then this thing here, the overall thing here, will be smaller than. If you omit this thing here, because this thing is going to be slightly above 1, if you omit this thing here, then this will be smaller than this denominator. This denominator here will be smaller than this denominator here, because you've just omitted something that's slightly bigger than 1. So this denominator here will be smaller than this denominator here. Well, if this denominator here is smaller, then the overall thing here will be bigger than the overall thing here. So we can say that the whole area here will be bigger or equal to this thing here. Now, by now you should be able to recognize that. Well, 1 over x looks like this, 1 and 1. 1 over x squared will look like this. So 1 over x squared will look something like this. So in the region of 0 and 1, this thing here is going to converge. This thing here is going to converge. Well, if this thing here is bigger or equal to this thing here, if the bigger thing converges, then the smaller thing will have no choice but to converge. So meaning this thing here will converge. This thing here will converge. So now we need to tackle this. So let's try and establish if this will converge or if it will diverge. So let's have a look at this thing here. So that thing there is the same as this. So now we need to establish if this thing here will converge or if it will diverge. So let's just multiply this out. That will then give us this thing here. So now we need to compare this with this, and the reason for that is in the region of 0 to, in the region from 1 to infinity, in the region from 1 to infinity, this thing here is going to be a positive amount. So your square root will look like this. 1 here, square root of 1 is 1. So from 1 to infinity, so in this region here, from 1 all the way to infinity, this line here will always be bigger or equal to 1. So in the region of from 1 to infinity, this is going to be a number that's going to be bigger than 1. It's going to be a positive amount. So here you've got one thing. If we omit this, if we just throw this away, so here you've got one thing plus a tiny amount here. If you throw this tiny amount away, then this thing here will be smaller than this thing here. Well, if this thing here is smaller than this thing here, then the overall thing here will be bigger or equal to this thing here. So we can say that this whole thing here will be bigger or equal to this thing here, which is the same as this thing here. And then we know that this thing here, well, when you get to this stage here, you should visualize this diagram in your mind. Hang on. You should visualize this diagram in your mind. 1 over x. So this is 1, 1. So 1 over x is 1 to the power of x. If you have a number that's bigger than 1, it's going to look something like this. So in the region from 1 to infinity, this thing here is going to converge. And we've seen this many times, so you should know that. So this thing here is going to converge. But then this thing here is bigger or equal to this thing here. So remember, this thing here is going to be smaller. I don't know what it will look like, but it's going to be smaller. It's going to be smaller. So if this thing here, which is this line here, if this line here converge, then the smaller one will have no choice but also to converge. So because this thing here is going to converge, this will have no choice but also to converge. So going back to the right to the start, we were trying to evaluate this here. Because it breaks down dead on 0, we need to break it down into two separate integrals. From 0 to 1, we've already established that this is going to converge, and then we've just seen that this thing here is going to converge. So you've got something that's going to come to a definite number. This is going to come to a definite number. Add the two together. This thing here is going to be a definite number, meaning this thing here will converge. So we don't know, at the moment we don't know, we don't precisely know how to work out the exact area. We just now know that the area is going to converge to a definite number. So this thing here is going to converge, even though we don't know what the precise area is. We don't know how to work it out yet. Okay, so this thing here is going to converge. All right.